like it means nothing.
Good evening. Hi, everyone. Welcome to this talk. Will it run? Is the central question I'll be asking throughout this talk, really, as we look at how we can maybe bypass EDRs and AVs using command line obfuscation. To briefly introduce myself, my name is Wietze. That's a Dutch name. I'm originally from Amsterdam, but I now live in London, where I work in threat detection and response. I love doing research in my own time, as well as at work, and it is actually at conferences like these that I learned a lot and got inspirations for new talks. So it's honestly a huge pleasure to be able to present some of that, what I've done, back at Disobey. Sweet, so that was the boring bit. Let's talk about command lines. But maybe before we do, I think most of you, right, I can assume a very technical audience, but I thought it was good for maybe those of you who are new to take 1 minute and just remind ourselves why we do what we do. Just 1 minute. Because there's a bit of a trend going on. This is a stat I've taken from CrowdStrike's Global Threat Report, and they notice a shift in the types of intrusions they observe in enterprise. As you can see, since 2019 until 2023, data for last year wasn't there yet, they notice an increase in malware-free intrusions. What they mean by that is intrusions where there is no traditional malware binary involved has risen to 3 in 4. So that means that threat actors increasingly use things that are native to a system, such as scripting tools. Think PowerShell, VB-script, on Apple and Linux, maybe Bash, but also LOLBAS, living off the land binaries and scripts. That's what I'll be talking about a lot today. We'll see lots of those. These are system-native applications with a legitimate purpose, but used for malicious means. And the same applies to legitimate third-party tools. Think AnyDesk, TeamViewer, right? Those are legitimate tools. Sometimes attackers bring them in to do bad things with them. So from a defense perspective, that means that the challenge now is no longer to detect the bad binary and block it, but it's to distinguish between legitimate behavior, benign behavior, and non-benign behavior of possibly, legitimate, signed, trusted executables. This is where command lines come in. So I hope you all know what a command line is. I'm sure you all have seen one. But the idea is that a command line gives some instructions to a program before it runs, right? So you have some context as to what the program should do, changing the execution flow without having to interact with the process. So very boring examples on screen, but just Notepad is an empty command line, but it tells you open a blank Notepad. The next one opens Notepad, but then with foobar.txt. Now, back to defense. This is useful information. As boring as this may seem, this is really useful. Because even without looking at the EDR telemetry, just by looking at the command lines, you can tell roughly what's going on, or you can see what the intent of the command is. For example, that third one, task kill, this one tries to kill Microsoft Paint. You don't have to look at API calls, you don't have to look at the raw telemetry. The command line tells you what the intent is here. And that fourth one is trying to save a registry location to disk. So the ones here look pretty harmless, right? But imagine the same executables, but now with this context. First one is still Notepad, but that second one is now interacting with the etc hosts file. Attackers sometimes do that to change DNS resolution. That third one is trying to kill Microsoft Defender. It doesn't succeed, it's blocked. But obviously, this is different from killing Microsoft Paint, right? And that fourth one is trying to export a location that contains sensitive registry keys that can be used to reconstruct hashes, such as password hashes. So context matters. And for that reason, EDRs and AVs love looking at command lines, because just by looking at them, you can try and block them, or at least alert people of them. And same from a forensic point of view, right? This sort of information is super useful to reconstruct what an attacker was trying to do. So you can imagine, if you're an attacker or in offensive security, you want to make sure that you don't get detected or that it is unclear from your command line what you're trying to do. This is where command line obfuscation comes in. So I define it as the masquerading of the true intention of a command, i.e. you're trying to obscure or to hide what you're actually trying to do and maybe bypass some defenses when you're at it. That might still sound very vague, so I brought a couple of examples. So the next few slides are just going to be examples of how you can do command line obfuscation, and I will show you how that bypasses EDRs. Later on, I'm going to show you how we do it at scale, but we start small, just to explain the concept. This is the most basic example I can give you. This is what we call option character substitution. On screen, you see a terminal, and well, let's look at the first one. It says PowerShell /EC, and then a base64 blob. If you've used PowerShell, this should look familiar. EC stands for encoded command. It just takes that base64 blob, decodes it, and runs the command inside. So in this case, it just says, "Hoi, Helsinki." Is that how you say it? Cool. OK, so the first one works. That's straightforward. Second one, exact same, but instead of a /, we have a hyphen. Is that interesting? Maybe not. We'll find out. But you can see that these are two distinct commands, but they result in the same output. Now, the next three look very similar, right? Like they look like they're actually just the hyphen all over again. Now, if you look closely at my process monitor window in front, so Procmon is an open source tool. It allows you to see some like internals of, for example, what processes are being run. I'll be using that today to show you what your EDR would see. Right? I don't know what EDR you use, but this should represent roughly what you would see in a security solution. If you look closely, you see that there is something wrong with these hyphens. Maybe 3 and 4 look very similar, but 4 and 5, like slightly different width, and that last one is at the top. Like what's going on? These are, in fact, 5 distinct commands. The first 2 were obvious, right? Regular / regular hyphen. But the next 3, they had different hyphens. They are the EN dash, the EM dash, and the quotation dash. So these are special Unicode characters. You sometimes find them on websites or even in Word documents with like the hyphens with different widths, but they're defined as a different character. And that means that even though they may look the same, like in my terminal, they look identical, don't they? But to your EDR, they are really different, as you can slightly see from Procmon. OK, now the so what, right? Because you might still think, OK, big whoop, 5 commands do the same, who cares? Well, your EDR may care. I take different vendors, and I by no means want to shame them, because these are all great resources, right? Elastic have a great resource where they define all their detection rules, so you can use it for inspiration or check your own logic. But I want to show you that through their open source logic that you can bypass them. Because in this case, they have a rule that detects the exact same we were looking for. PowerShell that either has -EC or /EC. So they're clever enough to realize there's 2 ways, the hyphen and the /, in which you can specify this command. But I hope you agree with me that the bottom 3 executions with the weird hyphen will not match against this logic, because it is not a normal hyphen, and your EDR will see the Unicode version. So by changing this single character that you can barely see with the human eye is different, we've actually bypassed this specific detection. So as I said, this is the most basic example. I hope you see where this is going, right? We make small changes to the command line. The output is the original, but the effect is that we may be bypassing defenses. This is an example for PowerShell. Let's look at another executable, because every executable behaves differently. This is MSI exec, the Microsoft installer executable. You can use it to install packages, like MSI packages. So that top command line there is very nice, because you can specify a URL, and what it will do is it will download the file and then install it to your machine. So in this case, it will download AnyDesk and install it in one go, single command line. So you can see why attackers might like that. Hopefully, you will have instantly noticed that the second command line does something weird. There's a couple of characters that look different. I applied the same trick, but just to other characters. Unicode is full of surprises, and there's lots of letters that are, by some executables, like MXI exec, interpreted as being equivalent. So these superscript characters, I think they're called space modifiers in Unicode language, you can just insert them, and MSI exec happily accepts them as if they are normal letters. Then the next three, I made more subtle changes, but you will have noticed that the URL has changed. I've changed the forward slashes to backslashes or backslash and a forward slash and vice versa. Very minor changes, and I hope you agree that this is not a normal URL, right? Lots of URL parsers would say, not a valid URL, can't pass that. But MSI exec is very forgiving. They're like, you know what, that's fine. Looks like a URL, then it probably is a URL. And as you can see, Procmon picks that up. So again, this is what your EDR would see. Another example of a detection rule, this is from Splunk. Again, they have excellent detection rules, so if you're interested, by all means, check them out. It's great for inspiration as well. They look for this exact sort of thing, MSI exec downloading something. They're clever enough to not include the word package. Maybe they know it can be bypassed, or maybe they realize we want to see all interactions with URLs. But I hope that you see here that it looks for MSI exec, and then the command line containing http:// or https://. So if we look at what we just did, those bottom three, even though we changed only 1 or 2 characters, would not be picked up by this specific rule. So again, small change, possibly a full bypass. I hope you're catching my drift, right? Let's see where this is going. So see if there's anything else we can do. So far, we've looked at character replacements. What about insertions? CertUtil, one of my favorite lolbas, is actually a tool meant for certificate management, cert utility. But maybe it's best known in our industry for being able to download arbitrary files to disk. So that top command is an often seen lol bin where you specify certutil -f -url cache. Then you give it a URL, and then the path you want to save it to. So in this case, it's going to save the home page to the txt file. Now, I hope you will also have seen that that second command line, there's something wrong with that, right? I've added a number of weird-looking Unicode characters to the world URL cache. Turns out certutil accepts a specific range of Unicode characters in the sense that it will just ignore them. It will see it, pretend it's not there, and then carry on reading. So the word URL cache is buried away in there, right? But it's just filtering out those weird characters. So it's a very specific range that it accepts. But it means, as you can see, that your EDR will no longer see the word URL cache. So another detection from the Sigma project, excellent open source resource, lots of detection rules. They have a rule for this, certutil, as you can see, process equals certutil, and then the command line either containing URL cache or verify CTL. Hopefully you can see, right, that first command line would be caught, second command line would not be caught, because the word URL cache is not there. Final one, more variations of this. I call this keyword obstruction, because I'm doing 2 different things here. This is about scheduled tasks. As the name suggests, you can schedule tasks with it. And this one simply creates a task that runs every 50 minutes, a bit like a cron job, right? Every 50 minutes, and then runs c windows temp/x.exe. Second command line, as you can tell from the output, also accepted. But then I added lots of random double quotes. Well, I say random, they have to be multiples of 2, and you need to make sure that you don't interrupt any spaces. For weird, historic, backwards compatibility reasons that I won't explain now, Windows loves double quotes. And you can pretty much, in nearly every executable, put them anywhere. But most importantly, they will show up in your EDR, as you can tell from the Procmon window, right? So create, SC, minute, like they're all no longer present in their original form. If you look closely, I hope you did, I also changed the path. It's still pointing to the same executable, but I applied a trick. So instead of c windows temp/x.exe, it now says c windows/disobey // whatever. This is a path traversal trick. So I hope you're familiar with this. If you navigate into a directory and then do /.. you navigate out of it. Some executables try and be helpful and they sort of resolve the path for you. So scheduled tasks, for example, they realize, OK, so if I navigate into disobey and then do /... that means I'm out of disobey, so I might as well ignore it. So the weird thing about this is that the folder disobey doesn't even exist, but it will resolve to C Windows/temp/x.exe, just with a lot more noise. And as you can see, it also changed the slashes. Again, why does this matter? This is a blog post I've taken from Logpoint. It's a good blog post on persistence techniques on Windows. They proposed this rule: schedule tasks with the /create for create a new task, and then they look for specific folders, such as C Windows temp. That's exactly the thing we try to do, right? In our obfuscated example, though, the word create is no longer there. You know, it's not, your EDR won't see the word create. And secondly, C Windows temp isn't there anymore. Not only because we changed the slashes, but also because of this path traversal trick. So very subtle ways in which I've now shown various techniques in which we can bypass these defenses. I hope you like that. But just to introduce you to the idea. Problem with everything I've shown you is anecdotal, right? These are just random nuggets of information I'm just blurting out here, and you might take a screenshot, a photo, and fix your detections later. But many executables have these flaws, but none of them are the same. They all have their own unique flaws, and that's because the person who wrote the program, or the development team, they decide how to interpret the command line. And that makes it hard. If you're an offender, you never know which trick you can apply, and if you're in defense, like myself, you never know how to write your detections to catch all the variations. So I thought, as part of my research, I want to solve this for once and for all, and we're going to find out how prevalent this is and how we can identify these techniques. So I'm going to now walk you through what I did, and then I'm going to show you the results. What did I do? I selected a bunch of applications, commonly seen law bins, things you would often find in intrusions. Then for each and every one of them, I applied a bit of black box testing. It's basically fuzzing, right? Like I just tried to work out for each of these executables what obfuscation techniques they were susceptible to. Like I'm not patient enough to reverse engineer everything and then work out all the intricacies. I just thought, gonna throw a command at it, gonna make as many changes of known obfuscation techniques as I know, see what sticks. On the back of those results, I'm going to create a model file which hopefully describes accurately for that executable what different techniques are possible, and maybe in what order, and whether you can combine them or not. And then hopefully that's a good abstraction of reality. But the only way to find out is to test it a lot. So I also then, in an automated fashion, tested my model to check if it generated accurate command lines, obfuscations that worked. And then if not, I would update it. And if I'm done, I'll have my abstraction. And that's something you can use both in offense and defense. So to bring this to life, because this is really boring and abstract, right? So let's bring it alive a bit more. I'm going to take a very simple one, ipconfig. It's not the most exciting law bin, but if you've used Windows, I'm sure you've run this command at some point. Because it's quite nice to find out your own internal IP. It's the easiest way to do it, as far as I know. But it does a bit more than that. If you use /all, it also gives you like your MAC address and lease times and gateway. So something an attacker also might do as part of discovery stage. All right, so we picked our application, ipconfig. Now I'm going to do my black box testing. So I defined, 6 or 8? 8 different obfuscation options, most of which I covered just now. But let's quickly go through them. Random case, we didn't really touch on, but in Windows, most things are case insensitive. But not all of them are. So let's check for an executable if it accepts differently coded, like uppercase, lowercase arguments. Option character we talked about. Character substitution, same, right? Different Unicode equivalents, hopefully doing the same. Character insertion, we saw lots of different characters there, but who knows, maybe even an emoji. Code insertion, I showed you. Shorthands I didn't talk about. That's basically deleting characters. So sometimes you have an argument like /foo. Some executables then also accept /fo or /f, right? So you leave characters out from the end. Sometimes that's accepted. So let's see if that works. And then alternative URL notation, we already saw. Same, right? Like change the slashes, and same with the file path notation. Change the slashes, use the traversal trick, that sort of thing. So I wrote a little script that you can access if you want. Here you see it in action. It's called Analyze Obfuscation. It's a Python module. It also works for other platforms. Today I'm talking mostly about Windows, but also works for other platforms. And it's simply, you give it a command. So here you can see I gave it ipconfig/all. What it then does, it just in parallel runs hundreds of ipconfig/alls, changes small things like the option character, tries to apply different Unicode characters, and then it just reports on the outcome. This is the short version, because as you can imagine, Unicode space is quite big. And then if you do that for insertion and in substitution, and then try it for different characters, it can take quite a while, even when you parallelize it. But if you finish it, so I'm going to move forward because this is boring, towards the end, you get a nice, in your UI, you get a nice sort of like summary of what it found. So green indicates it found some stuff, and then if you navigate to the log file, you get a bit more detail as to what it found. So for ipconfig here, it found one option character substitution, but looks of it a lot of character insertions. So we've got a whole list there. That's useful. Then we see some substitutions. So it tried the letter L, and it found some weird Unicode Ls, many more than we found in our example of MSI exec before. And quote insertion worked, but no shorthands. So for our example, I ran this against the full Unicode space. This is my result. Random case, yes. Option character substitution, only one, but it still counts, right? You can swap a forward slash with a hyphen. It's something. Character substitution, however, many more. Character insertion, obviously a whole range. Code insertion worked, no shorthands. And URL notation and file path notation, I don't know, because ipconfig doesn't take either, to my knowledge. So not applicable. Cool. So my fuzzer gave me a hypothesis, because I tried specific Unicode ranges, specific characters, but I need to extrapolate that. I need to make some assumptions. So what I'm going to do next is create a model file, which is in my case just a JSON file. So I'm basically now just coding up the observations from my fuzzer, make some assumptions, maybe try different orders. But basically, I'm now trying to write a machine-readable version of what I think obfuscation options apply to ipconfig. So there's two components, the command and then what I call modifiers. Maybe let's start with the command. It breaks up the command in different parts. As you can imagine, a command line has different components. Not all of them are equal. On Windows, typically the first command line argument is the program itself. So in this case, I call it a command. And then the next argument is just a generic argument with a /all. But as you can imagine, sometimes you will pass a file path or URL. Random case, for example, usually applies to the program name and arguments, but typically not to URLs. Right? URLs are case sensitive. So it's useful to specify for your command what role it has, so that my assumptions can then apply to specific command line parts, command line roles. So in this case, I say random case applies to both the command and the argument, but option character substitution only applies to any arguments, / and a hyphen. Character substitution, you'll probably have seen it by now. This is an example of the letter L, but obviously you would specify it for any character you might encounter. All the letters of the alphabet, numbers, sometimes even quotes, right, have character substitutions. Character insertions are simply just a list. And again, you apply to specific types. Character insertion, for example, typically doesn't work on file paths. And then finally, quote insertion. Again, there's no arguments there, but you just say it applies to regular arguments. So I hope that made sense. So this is my abstraction. Now I have a model. Now I have this model, and it may, even though it's based on empirical evidence, it may contain some assumptions. We need to test it. So that's why I introduced, a few days ago, invoke argfuscator. As the name suggests, argfuscator is argument obfuscator. It's a PowerShell module, really, that allows you to provide one of those files that I've just shown you, and it will then just spit out all sorts of obfuscated command lines with probability. Because so far, we've only looked at isolated cases. I've showed you code insertion and character substitution all separately. But would it still work if we combine them? That's my hypothesis, right? So if you run it, as you can see on screen, invoke argfuscator, you give it the JSON file, then you specify a number, and then it will return the number of arguments. So in this case, according to my model, these are valid commands. Now, before I started this presentation, I like to think that many of you would look at this and say, that's never going to run. That looks corrupted, man. That's not a command. That's just garbage. What's an emoji doing on a command line? That's all nonsense. But will it run? Only one way to find out. So what I've done, so again, just to show you how it works, you just press the JSON file, and then, maybe I should start it. The JSON file, and then the number of commands you want. I deliberately put the obfuscation level really high, so it looks really like garbage. Then I wrote a little PowerShell wrapper that takes these commands, executes them, and then checks the output. Like, is the output what you would expect from ipconfig? Look at the exit code, maybe look at the standard out. So that's what I've done here. And then, well, you can see what it does here. If it sees the expected output, you see the word success. So I think in this demo, it's doing it 100 times. So we're just going to let it complete. Hopefully, you get 100 successes. But for most of my testing, I used at least 1,000, just to, it's probabilistic. It generates different commands every time, just to make sure that all the variations and all the various orders will work. Now, I like this because it's all successful. But you might still not believe me because it's not showing the output on screen, right? So let's just copy one out, and let's put it in my terminal, and then will it run? What do you think? 1, 2, 3. Boom! Of course it did. You knew where this was going. You knew where this was going. So yeah, even though that looked really not like a command line, it did work. So that's great. So in this case, I already had refined my model. Sometimes you will find combinations that don't work. You need to go back and maybe change the order or change the arguments. But that meant that we now have a working test file and therefore have an abstraction. So that completes the cycle. For one executable, we've now done this. We picked it, we tested it, black box tested it, created our JSON file. I've then tested it, and then after trying it 1,000 times in different probabilities, I'm pretty confident that it is a reflection of ipconfig. Now, that was just one, and maybe not the most interesting one. But for my research, I've applied the same methodology to these 68 you see on screen. So I've taken these from the LOLBAS project. I've taken these from Atomic Red. So these are executables you can reasonably expect in an intrusion. These system-native executables used for bad. I tested them against a recent long-term version of Windows 11, 23H2. And let's look at some results. Because how can I share the results with you in a way that is approachable? Like the JSON files were useful, but again, if you're a defender, maybe that's not very helpful when you're running the detection. So that's why a couple of days ago, I've launched argviscator.net, which is a website making life a little bit easier, which documents all these findings. So you can look up an executable, and it tells you exactly what types of obfuscation it's susceptible to. But it doesn't stop there. And this is the thing I really like, is that it allows you to generate command lines. So similar to invoke argviscator, you just paste the command line, even easier. You don't have to define it. You click apply obfuscation, and it spits out an obfuscated version. It has a full-blown editor, so you can choose like disable certain options, or maybe make the probability more or less likely. You can make it as subtle or noisy as you want. But yeah, it's hosted in TypeScript. It's developed in TypeScript, hosted in GitHub. Important to point out, it is self-contained, so I don't store any results. And you don't have to believe me, because you can obviously clone it or use the offline version, but it really is meant to just be an aid rather than some sort of spy tool. And you can hopefully create yourself because of that full-blown editor. So let's take a look, because talking about it is one thing, but seeing it in action obviously speak a lot more words. So argviscator.net, let's try our ipconfig example, so ipconfig/all. So as you can see, it then tokenizes it for you. So it recognized ipconfig is probably the program name, /all. It thinks it's an argument. But if you think it's wrong, you can click it and change the type so it interprets it properly. Now, when I entered it, it recognized it. It is one of the executables I found out. So it very nicely shows us all the different the configs that I assumed it to be the case. Again, you can see for each type, it specifies what command line rule it applies to. Now, there you can see there's a lot of set replacements. We see the option characters, insertion, all that jazz. You can also see there's probabilities. So right now I'm using the default ones, but you can change them. You can make them very unlikely or more likely. But yeah, even without changing the options, just clicking apply obfuscation is now going to give me different command lines. So does it run? Only one way to find out. I'm going to copy out one of the results, and hopefully we will get a result. So as you can see, compared to my previous example, this one is default setting, so it's not as noisy. But again, to me, this doesn't look like a normal command line, and I hope you would agree with me, but it does work if you run it. It doesn't complain, works as expected. But ipconfig, I think we've seen now. That's also a bit boring. Let's go back to certutil. I hope you remember that one from the start of this presentation. We used certutil to download a file to disk. So certutil /f/URL cache. Then you give it a URL. So in this case, I've prepared one. And there it goes. And then I'm going to output it to surprise.png. But maybe for obfuscation reasons, let's add the full path so we can obfuscate that too with other tricks. So c/disobey/surprise.png. If you normally do that, Windows Defender is going to block it. So Windows Defender is one of those EDRs that recognize, or AVs, I guess, that recognizes command line arguments and blocks it because it knows this is a known download trick. So access denied. As you can see, my folder is empty. File's not there. Let's put it in Obfuscator. You can see now it recognized the URL as a URL and the path is a path. That's helpful. If we look at the options, you can see, right, these are different from ipconfig because every executable has slightly different intricacies. As I was saying before, let's change the probabilities to generate like a really noisy one, like one that really looks crazy. So I'm going to set the probability to 1 to a bunch of these. Yep, not going to change any of the other options. And then just click Apply Obfuscation. Looks pretty wild, right? Now, let's pick one. I'm going to copy it out. And then the question once again is, will it run? Again, I think prior to the start of this project, I would never have dreamt this to be a valid command that does, the thing at the top of your screen. But yeah, once I press Enter, you will see. Will Windows Defender block it? It's also a good question. Of course not. Command completed successfully. And now let's find out what was in that file. What is in the surprise? Disobey, surprise. So it did work, right? Oh, that looks familiar. Awesome. So yeah, we successfully downloaded the logo of this conference, and even though Defender tried to block it, just applying the obfuscation allowed it to go through. So yeah, this was just one example. certutil is one of my favorites, but these are some other of the pretty wild ones. As I said, I tested 68. Some of them are not really that interesting or very subtle, but some of them are really wild. So these are one of the more wild ones. Robocopy there. Even @find is a third-party binary, but again, accepted really strange Unicode versions. And then maybe NSLOOKUP, so the penultimate one. There's also one that I think should be on the list of shame. It's really weird. It just looks at the first 2 or 3 characters of an option, and then anything after that, it ignores. So it's not even specific Unicode ranges. It's like the entire Unicode space. It just ignores it after 1 or 2 characters. So you see -type, but then all sorts of Chinese, Mandarin, Arab characters combined. Doesn't matter. It ignores it. So there's lots of opportunities there to, well, definitely full EDRs, but maybe even analysts, because you can input anything there. Sweet. All right. If you're in offensive security, I think it's pretty sure what you can do with my tool, arcfuscator.net. If you're in defense, as I am, let's have a quick look, because this might look hopeless, but it's actually not that bad. Because now, like myself, that was the main reason for this research, you have a resource where you can check all the known obfuscation options for. So if you don't know whether to use a slash or a hyphen or whatever, like there's now a universal resource where you can find all the answers. So hopefully this helps. Similarly, you can generate command lines. So if you write a new detection, maybe check it, obfuscate it, check it if it either the detection rule still catches it, or if there's another detection rule that finds it. So test your command lines, and maybe if you have like detection as code sort of things, think about using invoke arcfuscator in your CI/CD pipeline. You could automatically test if any new detection rules are also caught by any obfuscation types that we know of. Sweet. Some statistics. There is a really cool comparison page, which I will show in a second, where you can combine all the different executables. But I found of those executables that I picked, 93% is susceptible to the quote insertion thing. That was much higher than I thought, and that is a bit problematic because that one is also perhaps hardest to detect, but I'll get to you in a second on that. But quote insertion, by far the most prevalent. Option character substitution, 72. Again, sometimes it's just a slash and a hyphen, but sometimes, I think there's one where there's like 15 different Unicode versions of slashes and hyphens it accepts. Pretty wild. 1 in 4 either character substitution or insertion, so the Unicode replacement or the Unicode insertion. 1 in 4, still, I thought, pretty high. Shorthands, only 6%, and then URL notations, so of those 68 that did support a URL, 16% you could use URL tricks like the slashes, or even in URLs you can sometimes apply the path traversal trick. So this is the comparison page I was talking about. If you go to the website, click all entries, you can see it there. But if you look at this matrix, it may look pretty daunting. As a defender, you may think, what hope is there? Sometimes you can do it in the detection rule itself, just take it into account. But sometimes you can just write one rule that covers all of them. For example, number of quotes. If you have a command line with just a high number of quotes, that in itself may be suspicious. Or even if you look at a quote that's in the middle of a word, you'd be surprised how rare that is in most enterprises to have like 1 or 2 quotes in the middle of a word. So even though this looks like 93% looks really problematic, you can possibly catch them all with one rule. Same with Unicode insertions and replacements. Again, check in your prod maybe next week. How many command lines do you have with like proper high up Unicode characters? Like not like characters with accents. I'm talking about like these weird superscript things. Maybe just detecting high Unicode ranges will do the trick. Doesn't have to be difficult. And I've already seen people try some other things as well, statistical analysis, like the random case one. I always think is a bit daft because most EDRs are case insensitive. But detecting command lines with a weird uppercase, lowercase ratio might also indicate someone is trying to hide something. So have a think. Again, look at the answers, because for all these executables that I'm sure you will have detection for is now documented, see what you can do there. Doesn't have to be difficult. Sweet. A couple more minutes left. But what does the future hold? I hope this shows you that this problem will not go away anytime soon. This problem has been around for a while, and that is because all these, including ipconfig, all these executables have to be backwards compatible. Microsoft being Microsoft, if they now change some of these behaviors, it's going to make people angry because they rely on all these weird customs. So even if Microsoft fixes the problem today, problem is that attackers can bring in vulnerable versions in new attacks. So we need to learn to live with it. Another key point I want to make, don't rely on command line arguments. What I mean by that is not that you shouldn't use them, because as we've seen, it's great, right? You can detect stuff. Windows Defender blocked something because it thought it was suspicious. So it's better than not doing anything, right? But don't rely on them, because as we've seen, you can bypass it. So, and this is just one way. There's obviously other ways in which you can spoof command lines. So what I would encourage you to do, if you're a defender, think about what is the underlying behavior. So that's certutil example, right? Microsoft blocks it based on the command line arguments, which is fair, but can be bypassed. What if it was instead looking for certutil writing something to disk right after it made a network connection? Maybe something that isn't a certificate, right? That in itself is probably more reliable, because EDR events are really hard to properly fool. So rather than command lines, maybe try and rework your detection to look at the actual raw events, file events, network events, DNS events, you know the drill. So don't rely on them. Use them, but don't rely on them, would be my call. Thirdly, you may be sitting here and think, ha, Windows being stupid, and you're right. Windows is pretty wild. I think command line obfuscation-wise, they are the worst. macOS and Linux, however, have their own weirdness. I have done research on this before. It's not on Obfuscator yet, but it will be coming in the next few weeks. So keep an eye out for that. They have their own weird versions, not as wild as Windows, but their own versions that make detections hard, maybe even harder than the Windows ones. So maybe the problem, in a sense, is bigger. So keep an eye out for that. Cool. Call for action. Stay involved. if you like this, and whether you're in offensive or defensive security, keep an eye out for this. This is useful stuff, right? Not all EDR vendors are looking for this right now. In fact, I would say most don't. But obviously, that's going to change. So look at the project, bookmark it, see how you can use it. If you're a defender, obviously check your detection logic, either of the tools, but also call for contributions. Right? My research is also it's not perfect because I used specific Windows version and I used specific command lines. But command lines are hard. They have different components. Sometimes they have different settings or different, like if you put a command line in, it might get it wrong. That is the reality. It's a probabilistic model, so you don't know. So if you find any flaws, please report them. Or if you want to support new executables, also please contribute. The website offers an editor, so you can try it for yourself, and you can upload your own contributions there. But yeah, I hope this gives you an idea of what command line obfuscation is and how Arcfuscator is trying to solve this problem for both sides of the coin. So thank you very much for your attention. If you want to stay in touch or have any questions, feel free to reach out any of the socials or come find me afterwards at the bar. That's it.